So we'll start with question 5, it looks like. So the law of multiple proportions, basically what it looked at when we talked about this in class, from the law of multiple proportions, we were basically looking at any compound. For it to be that compound, it needed to be found in the same ratio of the elements. So the example I gave you in class when we talked about this was we compared water to hydrogen peroxide, and we said, same elements, hydrogen and oxygen, we change the ratio. If we change the ratio, we're changing the properties, right? It can't be the same thing anymore. So can't be these, can't be these, can't be these, because they have to have the same two elements. We're just changing the ratio of those elements. Those first three examples, A, B, and C, they don't have all the same elements. So if we take a look at D, right, and E, and I apologize, D is way up there, but right, if we look at D and E, you can see E doesn't make sense either, but D, carbon monoxide versus carbon dioxide, right, we're changing the ratio, even though we're not changing the elements involved. So that's an example of the law of multiple proportions. Question 6, right? Which of the following is an isotope of selenium? So isotopes, right? Same number of protons, so they have to be the same atomic symbol. And if you have questions, just make them public questions, so like everybody can see the question and we can all learn from it. And then that way it doesn't look like I'm talking to myself answering private questions. Right? We all have questions, so we can all benefit from those questions. So which of the following is an isotope, right? Selenium, 75. So same number of protons means it has to have the same atomic symbol. This 75 is the atomic weight. So that's what's going to change as we get more or less neutrons. So we can cancel out a few of these, right? Can't be mercury. Mercury is not selenium, right? Can't be germanium. That's not selenium. Can't be bromine. That is also not selenium. Can't be arsenic either, but it could be selenium 80, right? It's got the same atomic symbol, so it's still selenium, but a different atomic weight, which means it has a different number of neutrons. Can't change the number of protons, right? That would change the element we're working with. All right, this first video is going to be pretty short, I guess. Question 11, maybe we'll add in question 17 as well to it. If you've got any questions along the way, feel free to jump in, all right? All right, question 7, everyone's favorite topic, scientific notation. Express the following number in scientific notation with the correct number of significant figures. So all of these first preceding zeros don't count, right? Those, nothing, I wasn't measuring anything there, so nothing shows up there. But because I include this 0, right, I recorded, right? That 0 is after measured numbers, which means I recorded that 0, which means that 0 is significant. So I should have 4 significant figures. So to put this into scientific notation, I'm going to move that decimal place over 1, 2, 3, 4 times. So 1.930 times 10 to the minus 4. And again, we're going to include that 0 and say that 0 is significant because it comes after real numbers. The only reason you would list that is because you were able to measure that place. If you weren't able to measure it, you wouldn't list that 0, and it would just be 1.93 times 10 to the minus 4. So it should be 4 significant figures. So to answer Zayad's question, right? So if the number of atomic weight is like 50, as long as the symbol still said selenium, that's what we're looking for. I mean, it's not realistic, right? Selenium is atomic number 34, so it would be hard for it to have an atomic or have um, atomic weight of 50. But what we're looking for is the symbol to be the same, right? That symbol needs to be the same for it to be the same element. All that changes is the mass, and that's what makes it an isotope. So sure, hypothetically, this could be 50. Realistically, no, there's no way. With an atomic number of 34, it's not likely for that to be 50. Right, this exam should be similar. It's the practice exam, similar coverage of the material, similar questions. If you are in an 80-minute class, your in-class exam is going to be a little bit longer. And if you're in the 55-minute class, your exam is going to be a little bit shorter. And when I say a little bit, maybe like one question shorter. I think I ended up making the 80-minute exam 30 questions long and 24 questions long for the 55-minute. All right, last question from this block of questions, right? When a metal, not what I wanted to do, when a metal and a non-metal react. And I got a few emails about this, but right in the question, it said you need to use these words, right? So sure, there are other words we could pick from, but it's like this is the word bank we were given for this problem. So when a metal and non-metal react, right, the metal tends to lose electrons and the non-metal tends to gain those electrons. And I guess we need to write non-metal for it to be accepted, right? And we form an ionic bond, right? So metals, the left side of the periodic table, they react and lose electrons. Our non-metals, the right side of the periodic table, when they react, they want to gain those electrons, becoming an anion, a negatively charged, but come together to form an ionic compound.